This circuit is the half-wave rectifier. For an ideal diode, it conducts for half the cycle and does not conduct for the other half. For a real diode, we can model it by the battery plus resistance model, that is the piecewise linear model. When Vs is less than Vd0, we have this equation. When the situation is opposite, we have this equation. This results in this transfer characteristic. However, as is the case in many applications, Rd is much lesser than R. So we can rewrite the second equation as V0 is approximately equal to Vs minus Vd0. This will result in this output. Notice that there is a gap here between V0 and Vs. This is the time when the diode is not conducting because Vs is not greater than Vd0. This is the half-wave rectifier in multisim. It is a very simple circuit and we have taken two outputs. This one A, it displays the input voltage V1, and this one B displays the output across the resistor. Now we play it and we see the output. You can see that the output is exactly like we had in our lecture. This is an oscilloscope, and this is available over here in the right side panel. An important quantity we will see here is peak inverse voltage, PIV. It is part of the specification a designer must have to ensure that diode is selected correctly for the design. The PIV is the maximum reverse voltage that the diode must be able to withstand without breakdown. This voltage must appear across the diode. In this figure and in this figure, we see that diode is cut off when Vs is negative. The largest such voltage is the peak of Vs here. So PIV for this circuit equals Vs. Note that if input signal is small, the circuit will not function properly. For example, a signal in millivolts will not be able to cross the threshold Vd0, and the diode will always be cut off.